Hello, all my 9th standard young friends. This is the annual examination, that is the pre-board examination paper of class 9 2020, which means the pre-board's examination that finished this year in the month of February 2020. This is the mathematics paper. The paper is for 2.5 hours, and also with first 15 minutes given to you to read thoroughly. And then we have two sections. We have section A, which is 40 marks. Section A has 4 questions, each 10 marks. So question 1 to question 4, they will be of 10 marks each. Mostly the marking scheme is 3, 3 and 4 marks. Okay, then our section 2 will have 7 questions. We have to attempt any 4 of them. So when we get our first 15 minutes, ideally you should read section B first and decide on which questions we want to attempt, where we will lose the least marks, and then we come to question number 1. Now, are we ready to solve the question paper? Let's begin. Our question 1 of section A starts with rationalizing. Can you see this 4 upon root 5 plus root 3? We have to simplify this and find the value of this fraction. And we have been given root 5 and root 3 values. So how we start with this? By rationalizing this fraction. So we have written the question down. Now we will write the fraction the way it is given. And because the denominator is of the form a plus b, we will rationalize it with the form a minus b, which means root 5 minus root 3, and the numerator also will be just the same. That will give us in the denominator root 5 whole square minus root 3 whole square, because we are using a plus b into a minus b equal to a square minus b square, and in the numerator we have that will now simplify it as 4 into root 5 minus root 3 upon root 5 whole square is 5, root 5 into root 5, minus root 3 whole square is root 3 into root 3, which is 3. That would give us 4 into root 5 minus root 3 upon 2. 2 1s and 2 2s will give us. Now, just to save on space, I am going to make a column. In the exam, please continue to write one step below the other. But here, just to save on space, I will use the column. So it will now become 2 into bracket root 5 minus root 3. Now, this apparently is the answer if they had not given us these values. So now we will have 2 into root 5 is 2.236 minus 1.732. So it becomes 2 into bracket 6 minus 2, that is 4, 3 minus 3, 0. And when we multiply by 2, and this is our answer. Let us look at question number 1b. If x minus 1 upon x is equal to 1 upon 3, evaluate x cube minus 1 upon x. And now let us solve this. We have been given x minus 1 upon x is equal to 1 upon 3, and we want x cube minus 1 upon x cube. So we will have to take the cube of both sides. So we use the formula for a minus b whole cube. A cube minus b cube minus 3ab into bracket a minus b. This is the formula for a minus b whole cube equal to. So this is our thinking step. We will use just this and we will now write our next step. Therefore, x cube minus 1 upon x cube minus 3 into x into 1 upon x into x minus 1 upon x, and that is 1 upon 3 whole cube. 1 cube is 1, 3 cube is 27. Now we have therefore x cube minus 1 upon x cube minus, it will be 3 into bracket x minus 1 upon x, which is 1 upon 3, and that is, so as you can see, we have this minus 1 transferred this side. You will have 1 plus 27 in the numerator. That gives us 28 upon 27, which is the answer, but we will write it actually as 1 and 1 upon 27. We convert it into a mixed fraction and we write it as our answer. Question 1c. In the given figure, ABC is the triangle, D is the midpoint of BC, AD produced 2E. Let us look at the diagram. AD is produced to E. Can you see that? AD is produced to E, and BM and CN are two perpendiculars dropped from B and C. Can you see that? BM and CN, they are the perpendiculars dropped on AE. We have to prove that triangle BMD is congruent to triangle CND, and the second, BM equal to CN. Question 1c, we have drawn the diagram. We have BM perpendicular to AE and CN is perpendicular to AE, and we write what is given like so and what is to be proved, and then we will have the statements and the reasons columns. Statement number 1 saying D is midpoint of BC, which is given. Statement number 2, BM is perpendicular to AE. Statement number 3, CN is perpendicular to AE, and all this is given. Statement number 4, we take BMD triangle, which I will show with the dot, and CND triangle, which will be shown with the tick mark here, and you will see that this is 90 and this is 90 in these two triangles, and then we will have these two angles which are vertically opposite, and D is the midpoint of BC, so this is equal to this. So it is your AAS, or you can write it as SAA. So let us write in triangle BMD and a triangle CND. Now you pause this video and write down the angles which are 90 degrees, and here I am writing the reason. BM perpendicular to AE, CN perpendicular to AE, which is statement 2 and 3. Now look at your answer. It is BMD is equal to angle CND which is 90. Then we come to statement number 5. Again pause it. The two angles which are vertically opposite. Okay, now check your step. It will be MDB and NDC. Did you get it right? Good. Statement number 6, we will have BD equal to CD. This will be because of statement number 1, because D is the midpoint, correct? And 7th statement, therefore, can you see this is your A, this is your A, and this is your S? The test for congruency, triangle BMD is congruent to triangle CND, and this will be because of statement 4, 5, 6. And AAS, test for congruency. All right. This is your proved first part. Okay. Now we have to prove that BM and CN, they are equal. Now these two sides are opposite these vertically opposite angles. Can you see that? So they are the corresponding sides, and corresponding sides of congruent triangles will be equal. Statement number 8. Therefore BM is equal to CN, and this will be from statement 7, and C, P, C, T, C, corresponding parts of congruent triangles are congruent, and that is your proved 2, and we put it in a box. And so we have finished with question number 1. Question 2a says evaluate, and this is given. This is from chapter indices, and so we are going to just copy this and we are going to use the laws of exponents and we are going to solve this. We have minus 1 upon 4 bracket to the power minus 2 minus 3 into this we will write as 2 to the power 3 and that to the power 2/3 multiplied by 4 to the power 0 is 1 and plus it will be here 3 to the power 2, 16 is 4 to the power 2 and the whole bracket is to the power minus half. That is equal to, now we are going to make this negative power into positive by making a reciprocal of this, because x to the power minus m will be 1 upon x to the power m, right? So it will be minus 4 upon 1 to the power 2 minus 3, and now this and this will multiply, so we will write it like so. This multiplied by 1 does not make any difference. Here this is again negative power, so we'll make it as positive. So 4 square upon 3 square bracket to the power half. This gives us minus 4 square becomes 16 minus this gets cancelled, 3 multiplied by 2 to the power 2 and plus here this is 4 upon 3 bracket to the power 2 and that to the power half. So we will have 16 minus 3 into 4 plus this will be, now 2 into half will get multiplied and we will have plus 4 upon 3. That is 16 minus 12 plus 4 upon 3. That gives us 16 minus 12 is 4. So it will be 4 plus 4 upon 3 is 1/3. You can take LCM also, not a problem. So I am just going to stop at this and this is our answer. So here we have question 2b. Using ruler and compass only, construct rhombus ABCD with AB equal to 6 centimeters, diagonal AC 7 centimeters, and hence measure and write down the length of the diagonal BD. So first we will draw the rough diagram. I'm just going to show a rhombus. Each side is 6 centimeter. It was given to us, and diagonal AC is 7 centimeters. Once we draw the diagram like this, it is easier for us to understand the construction. We will draw AB first, then we'll take the radius 6 centimeters, draw the arc, 7 centimeters, draw the arc. So you'll get your point C. From here, we'll take 6 centimeters. From A, we will take 6 centimeters where they intersect. That will be our point D, and then we join this. Okay, so let us see how we can do this. That is just 6 centimeters. Now we will take the radius equal to, let's check this, is it 6? Okay, so we've taken 6 centimeters as the side. Now we will take 7 centimeters as the radius. There it is 7, and now keep the point of compass at A and draw an intersecting arc. So you see, I should have taken longer arc. So this is our point C. From C we need, this is 6 centimeters, yes. So from here 6 centimeters we draw the arc, and from A 6 centimeters we draw the intersecting arc. So we have this is point D. Now we will join we write the measures and we are asked to find the length of diagonal BD. Now because AC we have taken as 7 centimeters, I shall show this as dashed line, and diagonal BD we have to measure. So I will draw that diagonal and let us measure. I'm getting it as 9.6 or 9.7. It is between that. So we will write it as 9.7 centimeter and we will say BD equal to 9.7 centimeter. Now your examiner will have to give you marks even if it is 9.6 that you have written, because it is between 9.7 and 9.6 for me. So plus and minus a little bit of error is still agreeable and you will not lose your marks for that. Let us come to question number 2C. Mr. Ram borrows rupees 20,000 for 2 years compounded annually. The rate of interest for 2 successive years are 9% and 10% respectively. If he repays rupees 1,200 at the end of first year, 1,660 at the end of second year, find the amount outstanding at the beginning of the third year. So we've written the data here. The principal, that is the amount borrowed, is 20,000 times 2 years. R1, that is the rate for the first year, is 9%. R2 is 10% per annum. Amount repaid after 1 year is 1,200. Amount after second year repaid is 1,660, and we have to find out amount outstanding at the beginning of third year. So for something like this, I prefer to do P1, that is principal for the first year, that is rupees 20,000. Then your I1 is going to be 9%. So I will say I1 will be PRT upon 100, which is 20,000 multiplied by 9 into 9 to is 18. So we have the interest as 1,800. And so the amount after first year is rupees. Correct? Now we are going to have amount repaid after first year 1,200. So we will have amount outstanding we'll have to subtract this from here. Correct? Now this becomes the principal for the second year. So let us see how we do that. Your principal for the second year is rupees 20,600 and the interest for the second year will be, rate for the second year is 10%. Second year means time is 1. So the interest is 2060, and so we'll have the amount at the end of 2 years. The second year it's going to be like so. And now we will have amount repaid is going to be rupees 1660. So amount outstanding will be, when you subtract this from this, so it will be 0, 0, 0. Now we want the amount outstanding. If you look at the question, we need amount outstanding at the beginning of the third year. It means end of second year. Amount outstanding at the end of the second year, which means beginning of the third year. So 21,000 is your answer. Let us look at our question number 3. Without using the trigonometric tables, evaluate the following, and we have been given this. Now, without using trigo table means that you cannot use the log table to find out like tan of 30 or tan of 60. You cannot use the table, but you will have to use the standard angle table. Okay, first of all, you must have the standard angle table ready for this. So let us see how we solve this. Okay, question 3a, let's write it down. For our standard angles, we will write the standard angle 0, 30, 45, 60, 90. This is what you have to do in rough. This will be 0, half, 1 upon root 2, root 3 by 2 and 1. And then we will write 1, root 3 by 2, 1 upon root 2, half, 0, 0, 1 upon root 3, 1, root 3 and infinity. Now you need to know this by heart. Okay. Now in case you do not know the shortcut for this, I will put the link up somewhere on the right hand corner. So you will be able to see that video and know how to get the trick of remembering these values for the standard angles. Let us come to our question number 3. Now tan 30 is 1 upon root 3. And so cot becomes root 3 upon 1. Sec is 1 upon cos. Cos 30 is root 3 upon 2. So sec becomes 2 upon root 3 plus cosec is 1 upon sine. Sine 30 is half. So cosec becomes 2 upon 1. Tan 45 degrees is 1 minus 2 multiplied by cos 0 is 1. So 2 into 1. Sine 30 is half plus cos square 45. Cos 45 is 1 upon root 2 and that whole square. Now let us simplify this. Root 3 multiplied by root 3 upon 2 plus 2 minus 2 into 2 upon 1 plus 1 upon root 2 square. 1 square is 1, root 2 square is 2. So we have 3 upon 2 plus 2 minus 4 plus half. Okay, now I'm going to take this and this together. This will be 1.5 and half, that is 2. So I'll have this plus this, that is 4. 4 minus 4 is equal to, and that is our answer. Now let us come to 3b. Question 3b. Triangle ABC is right angle at B. M is the midpoint of BC and prove that AM square plus BC square is equal to AC square plus BM square. Let us draw the diagram and then we'll start solving it. So we have drawn the diagram and we have written what is given over here. Now we have to prove that AM square plus BC square. AM is the hypotenuse for this triangle. So we will say in right triangle ABM by Pythagoras theorem, we will have AM square is equal to AB square plus BM square. Okay. Statement number 2. They want BC, the square of it. BC is the part of this big triangle and that's also a right triangle. So in right triangle ABC by Pythagoras theorem, we will have AC square is equal to AB square plus BC square. And so statement number 3, we are not interested in AC square, we need BC square. So BC square is equal to AC square minus AB square. Statement number 4, we will take AM square plus BC square will be equal to AM is AB square plus BM square plus BC square is plus AC square minus AB square. Okay, which is equal to BM square plus AC square. Isn't that what we needed here? Okay, so this will be from statement 1 and 3, and this is where we say we proved AM square plus BC square is equal to BM square plus AC square. 3c. Construct a frequency polygon for the following distribution. Use a graph sheet. So this is our distribution table. We'll have marks which will be on x-axis. Number of students will be on y-axis. Marks are up to 90 and number of students maximum are up to 34. So let's get the graph sheet. Pause the video. Now draw the graph and match it with my solution. So 3c question is about frequency polygon and you will see that I have taken, this is your y-axis and I have taken the number of students. So I'll write here number of students. Okay, and you will see number of students, the highest is 34. So you will see that I have taken, you see, this is 20, this is 25, this is 30. Now this is a 2 millimeter graph. Between 20 and 25, there are 10 divisions. So each unit becomes 2 divisions. This is 21, this is 22, this is 23, this is 24, and this is 25. Okay, got that? Alright. On the x-axis, I have taken, as you can see, the values start from 30 going up to 90. So I have the values up to, there are 10 squares here. So this is 100, this is 90, 80, 70, 60, 50, 40, 30, 20 and 10, and this is 0. So this is the origin, which I'll write as O, and these are the marks. And we have taken 2 centimeters as 10 units, okay, which means each one of this is 1 unit. So this will be 11, 12, 13. In any case, marks are given as a group, so 10 to 20, 20 to 30. Now 30 to 40, the frequency, that is number of students, is 6. So from here to here, this is 5, and then 2 divisions, so that is 6. Okay, now between 40 and 50, it is 15 students. So we come up to, this is your 10, this is your 15, and this is how we make the rectangles. All right, we come up to here. Then 50 to 60, it is 28. So after 25, this will be 26, this will be 27, and this will be 28. So we draw the horizontal line, and then we will take this vertical line to make this rectangle. And then out here, this is 34. So you will see that this is 30, this is 35. So I come down 2 divisions. So that is my 34. I complete this rectangle. The next one, 70 to 80, is 18. So 18, this is 20. So this is 19 and this is 18. Or you can count from here, 15, 16, 17, 18, make this rectangle. And then 80 to 90, the frequency is 8, that is 8 students. So this is 5, 6, 7, 8. Or you can come down, this is 10, this is 9, this is 8, and make this rectangle. Now this is actually histogram that we have drawn if we make the blocks like so, the rectangles. Frequency polygon says that you take the midpoint of this class interval, midpoint of class interval. So you'll take the 5th division and mark it as a dot. For the first one, 30 to 40, the earlier class interval would be 20 to 30. So you mark the 5th division. All the midpoints of these are marked. For the last one, 80 to 90, you go ahead to 90 to 100. Mark the 5th division here. And keep all these points ready. And all you have to do is just join them like so, with a straight line, okay, with a ruler, and that is how you get your histogram. Now you will see that out here I have written the scale. Okay, can you see the scale that is written over here? So it should be written like so. All right, let's look at question 4a. A is a point on the x-axis and B is minus 7, 9. Distance between the points A and B is 15 units. Find the coordinates of point A. Now out here, you'll have to first draw the diagram. So let's just do that. Let's see the statements also. A lies on x-axis, and so let A equal to x comma 0. Remember, if the point is on x-axis, it becomes x comma 0. If it's on y-axis, it becomes 0 comma y. And we show the diagram like this. We write A as x comma 0, B as minus 7 comma 9, and the distance is 15 units. And so, because we are going to use the distance formula, all of you should know the distance formula by heart. Now remember, A is x comma 0, so we would have to have x minus minus 7. So my formula will not be x2 minus x1 whole square and y2 minus y1 whole square, but I'll keep it as x1 minus x2 whole square. We use the formula d equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. Now we have to specify what is x1 and y1, so we write it like this, okay? And then all we have to do is substitute. Your distance is 15. So under root x minus 7. Okay. And here it will be 0 minus 9. Alright. So when we are writing the next step, it becomes 15 equal to under root x minus into minus becomes plus 7 whole square. And here 0 minus 9 is minus 9 whole square. And so it becomes 15 equal to under root. This becomes x squared plus 14x plus 49. And here it becomes plus 81. We are using a plus b whole square formula, which is a square plus 2ab plus b square. Now we are going to square both sides. So 15 square will be equal to this. We write without the square root sign. So x square plus 14x and 49 plus 81 is 130. 15 square is 225. This we write as it is. Take 225 that side. So you will have 0 equal to x squared plus 14x minus 95. Okay. Now we have to factorize this. So we have x squared plus 14x minus 95, and that's equal to 0. So we will now write our product is going to be 1 into minus 95, that is minus 95, and we will have difference equal to minus 14. The factors of 95 will be 19, 5 is 95. So minus 19 and plus 5. Okay. So x squared minus 19x plus 5x minus 95 equal to 0. So x into x minus 19 plus 5 into x minus 19 equal to 0. So x minus 19 into x plus 5 equal to 0. So x minus 19 equal to 0 or x plus 5 equal to 0. That will give us x equal to 19 or x equal to minus 5. Therefore, A, which is going to be x comma 0, is 19 comma 0 or minus 5 comma 0. So these are the coordinates of A, and that is our answer. Question 4b is a geometry diagram. This one. Let us read it. In the given figure, ABCD is a rectangle whose diagonals intersect at O. Diagonal AC is produced up to E and angle DCE is 145. Find angle CAB, that is this one, AOB, that is this one, and ACB, that is this one. Okay, so first of all, we'll need to draw the diagram. Let's draw it. 4B diagram is ABCD is a rectangle and AC is produced, and this angle over here DCE, that is 145. We are to find out angle CAB. CAB is this, so I'll call that as small a. AOB, which is this, I'll call that as small b. ACB, this is a small c. So these are the angles we have to find in our given and find. We will write what is already given in the data, and then we will write the statements and the reasons. The first statement, we will write what is given. ABCD is a rectangle given. Now when it is a rectangle, we know that all angles are 90 degrees. So we write that. Statement 1, since angles of rectangle are 90 degrees each. And also we know for rectangle, the diagonals bisect each other. And the diagonals are also equal to each other. So we will write AC, which is diagonal, and BD, which is also diagonal of ABCD, and these diagonals are equal because it's a rectangle. Now, angle DCA, that is this angle over here, this 145 and this. So we are slowly going from 145 this way. Okay. So 145 and this. What is the connection? They are angles in a linear pair. So we write that. So DCA, this one is going to be 180 degrees minus 145, which is 35, because angles in a linear pair are supplementary. And so angle DCA, that is this one, will be equal to angle CAB, that is this one. This and this, they will be A and A because they are alternate angles. Why? Because your AB and DC, they are parallel to each other. And so we will have alternate angles are equal, and that's why even angle CAB will be equal to 35 degrees. So if I am looking at this angle, I need to know this angle, which is, we have found out that this angle over here is 35 because this angle is 35. So now if I have to find AOB, that is the second one, then I need to look at this triangle. Now in this triangle, I need to know AO and BO. They are going to be equal. So this will be 35, this will be 35 degrees. So we will write AO equal to BO. This statement number 3, which says AC equal to BD, we'll write therefore AC upon 2 is equal to BD upon 2. That is statement number 3. Now AC upon 2 means half of AC, and half of AC will be AO, and half of BD will be B. Therefore, in triangle AOB, look at your triangle AOB, we will have AO equal to BO, and therefore opposite AO will be angle ABO, and opposite BO is going to be angle BAO. They are equal to 35, 35. This angle plus this 35 plus this 35 will be 180 degrees, since angles of the triangle are supplementary. So see how we are writing it. You have the diagram in front of you. You have drawn it already, right? Statement number 6, as diagonals of the rectangle bisect each other, then in triangle AOB, angle ABO equal to angle BAO equal to 35 degrees. From statement 7, as angles opposite to equal sides are equal, and also from statement 5, which says these two angles are 35, and the diagram. Then we will talk about the 3 angles of triangle AOB being supplementary. We write equal to 180 degrees, see there. And so we substitute 35, 35 and AOB equal to this. And so we will have 70 degrees plus AOB equal to 180 degrees. So AOB turns out to be 180 degrees minus 70, which is 110 degrees. And that's our answer 2. Now we have to find this angle, this one, C. So we will take this triangle. Which one? Triangle ABC, because we already know that this angle over here is 90, this is 35, and this one, if you add to this, you will get angles of the triangle ABC. They are supplementary, so we write just that. So in triangle ABC, the 3 angles add up to 180 degrees because angles of the triangle are supplementary. And so 35 degrees plus 90 plus ACB equal to 180 degrees. That will be from statement 5, which said that the angles are 35 degrees each, and statement number 2. So angle ACB therefore is, these two go that side, 180 degrees minus these two, that will be your 55 degrees. And that is our answer 3. Question 4C. Find the altitude and area of an isosceles triangle whose perimeter is 64 centimeter and whose base is 24 centimeter. When we start solving something like this, remember tip number 1 is always to draw the diagram. So let's just do that. A diagram looks like this, triangle ABC, and it's an isosceles triangle. So we will show AB equal to AC, and we will call that as small a and small a. And the base we will call as B. Now we are given that the perimeter is 64 centimeter and the base is 24 centimeter. Perimeter is going to be AB plus AC plus BC. So it will be, in terms of A and B, it will be A plus B, correct? So 64 is equal to 2A plus base is given as 24. So we connect what is known with what is unknown, and so 64 minus 24 is equal to 2A. 2A turns out to be 40. A turns out to be 40 upon 2, that is 20 centimeter. Now we are expected to find the altitude. So altitude means you'll have to drop the perpendicular. So we will draw AD, which is perpendicular to BC. Let AD be the altitude. So BD equal to DC will be half of BC. See there, this BD equal to DC, that will be half of BC, because altitude from the vertex bisects the base. So each one of them will be half of 24. So we write like so. Okay, so this is 12 and this is 12 centimeter. Got that? Now, in a triangle ADB, Pythagoras theorem will give us, now we know CA is 20, So this is 20 centimeter. This is 12 centimeter. So using the Pythagorean theorem, we can find AD. So in triangle ADB, by Pythagoras theorem, we'll write hypotenuse is equal to sum of the squares of the other two sides. It's very simple. We are just substituting the values. Now when you are doing this, you have to draw the diagram first. Put it on pause, write it on your own and check with me whether you are right or no. Okay, and check the steps also so that the logical sequence also can be understood better that way. So AD square will be equal to 400 minus 144. That will give us 256. So AD will be under root that, and 16 square is 256. So we are going to get AD as 16 centimeters, which is the altitude, and that becomes our answer 1. Now, the second part they asked us is to find the area. So area of triangle is half base into height, correct? So that is half BC into AD. And so you will have half 24 into AD is 16, and that is 192 centimeters square, and that is our answer 2. Section B, which is 40 marks, and from this section we have to attempt any 4 questions. We are going to start with question number 5. 5A reads, if 13 sine A is 12, find sec A minus tan A. Question 5A says 13 sine A equal to 12. So we convert it into sine A equal to 12 upon 13. We draw this diagram and we will see this is our angle A, and your sine A is opposite upon hypotenuse. So opposite becomes BC, which is 12x units, and hypotenuse AC becomes 13x units. And then in this right triangle, we use Pythagoras theorem, and then we use AC square equal to AB square plus BC square. As you can see, this AC square is equal to AB square plus BC square, and substitute the values, and we will get our AB square as 169x squared minus 144x squared. So AB becomes under root of 25x squared, which is 5x units. So we will write here 5x units. Now we have to find the value of sec A minus tan A. Now sec A is 1 upon cos A, correct? And tan A, we know it is opposite upon hypotenuse. So cos is adjacent upon hypotenuse. So I shall write it as 1 upon 5x upon 13x becomes 5 upon 13, minus tan A is going to be opposite upon adjacent. For A, opposite is BC, that is 12x upon 5x, that is 12 upon 5. So we will write like so, and that will give us 13 upon 5 minus 12 upon 5, and that is 1 upon 5, and that is our answer. Question 5B reads, a sum of 10,000 rupees yields rupees 3310 as the compound interest in 3 years. If the interest is compounded yearly, find the amount and the rate of interest. So we have written 5B, principal, that is 10,000 rupees. Compound interest in 3 years is 3310 rupees. Find the amount. Now what is your amount? Your amount is going to be principal plus the compound interest. So that will be 10,000 plus 3310. So that will be 13,310 rupees, and that is our answer 1. Okay, now we come to the second part. The second part asks us rate of interest. So we are going to connect amount with the principal, and our formula is A is equal to P into bracket 1 plus R upon 100 to the power n. So amount we have already found out. It is 13310 is equal to principal is 10,000 into bracket 1 plus R upon 100. And remember, we have been given CI for 3 years. So n becomes 3. Now we are going to take this 10,000 this side. So 13310 upon 10,000 is equal to 1 plus r upon 100 to the power 3. 0 gets cancelled. Now if this is a cube, this must be a cube, and we know that it is the cube of 11 upon 10, and that is equal to 1 plus r upon 100 to the power 3. So you will see that the powers are same, so the bases must be equal. So taking cube root, we will have, now we transfer this one this side, so it becomes 11 upon 10 minus 1 equal to r upon 100, and so we get 1 upon 10 equal to r upon 100. So your r is going to be 100 comes this side, and therefore your rate is equal to 10% per annum, and that is our answer 2. Question 5c. In the given figure, O is the center of two concentric circles. A line L cuts the circle at ABCD. This is line L, cuts the circles at ABCD as shown in the figure, and OP is perpendicular to AD. This OP is perpendicular to AD. Given that OA is 34, this is 34 centimeter, OP is 16, and AB is from here to here, this is given as 18 centimeter. Find the length of the chord AD, this full thing, then the length of the chord BC from here to here, and the radius of the smaller circle, which will be OB. So we will be joining this when we draw this diagram. So let's draw the diagram and see what we can do. We have drawn the diagram here. You can see AD is the chord of the bigger circle, BC becomes the chord of the smaller circle, and these are concentric circles. We have been given OA is 34. So I shall write here 34 centimeter. OP is 16, and AB from here to here, this is 18 centimeter. Okay, now we have to find AD. AD is going to be twice of AP. Reason, OP is perpendicular to AD, and therefore the perpendicular from the center bisects the chord. So we shall write just that in our first statement. We will say that OP is perpendicular to AD, and that is given. Statement number 2, therefore AP equal to PD equal to half AD, and this will be from statement 1 as perpendicular from center bisects the chord. Now AP can be found out using this triangle. So we know that this OP is perpendicular, so this becomes a right triangle. So in right triangle APO, by Pythagoras theorem, we will have AO square equal to OP square plus AP square. Now we have to substitute. What I want you to do is draw the diagram, put it on pause, and then look at the solution, because each time I don't want to move this paper to show you the solution. So we are substituting. AO is 34 square equal to OP is 16 square plus AP square as it is, and so AP square will be equal to 34 square minus 16 square. So I'm going to make it as 34 plus 16 and 34 minus 16. This gives me 50 multiplied by here it will be 18. So my AP will be under root of that. So this will be under root 2 into 25 into 2 into 9. That will give me 2 into 5 into 3 as the value of AP. AP will be therefore 30 centimeter. Now we are asked to find AD. So you will say statement number 4. So your AD is going to be equal to twice AP. Statement number 2. So AP is half AD. So AD becomes twice of that. So 2 into 30, which is equal to 60 centimeter. And that is our answer 1. Now the second part says BC equal to how much? So let us look at our diagram. We want BC, so we need to use triangle BPO. From here to here, this is AP, and AP came out to be 30 centimeter. So your BP will be from here to here. This is going to be 30 minus 18, and that will be 12 centimeter. So in this triangle, you can find BP is 12. So BC is going to be double of that. Okay. So we come to statement number 5. We will say that BP is equal to AP minus AB because of the diagram. Now AP is 30 centimeter minus AB is 18 centimeter, and this will be from statement number 3 and given, which comes out to be 12 centimeter. Now this is your BP. Now if you look at your diagram, you will see that OP is perpendicular to BC as well. So let us write it OP perpendicular to BC, and here it is again given. So seventh statement will be your BP equal to PC equal to half BC. This will be from statement 6 and perpendicular from center bisects chord. Bisects the chord. Alright, so you will have therefore BC will be equal to 2BP, which is 2 into 12, which is 24 centimeter, and that becomes our answer 2. We have to come now to finding the radius. Now let us look at the diagram. In a triangle OPB, you will see that OB is the hypotenuse, OP is 16 and BP is 12, and OB is the radius of the inner circle, the smaller circle, correct? So this is nothing but OB equal to question mark. So we will take this triangle, which one? OBP. So we've written just that. In write a triangle OPB by Pythagoras theorem, OB square is equal to OP square plus BP square. OP is 16, so that is 16 square plus 12 square, which is BP square. 16 square is 256, 12 square is 144. Add them, you get 400. OB will be under root that, which will be 20 centimeter, which is the radius of the inner circle, and that is our answer 3. That finishes our question 5. Now we come to question number 6. A. If the mean of the observations A plus 6, A plus 2, A plus 8 and A plus 4 is 11, find the value of A and the median. So first of all, we will write all these observations. We'll write what is the mean, and then we'll proceed to find A. So we've written mean 11 and the formula for mean, because if mean is given as 11, we need to know the formula for mean, which is sigma x upon n. What is x? X represents the observations. How many observations are there? 1, 2, 3, 4, 5. So that is going to give us here, mean is 11. So 11 into 5 is 55 is equal to 1, 2, 3, 4, 5. So 5A plus 6 and 2, 8, 8, 16. 16 and 4, 20. Okay, then we will have 55 minus 20 is equal to 5A, and that will give us 5A is equal to 35. Therefore, A is equal to 35 upon 5, which is equal to 7. So your A is equal to 7, and that is our answer 1. Now this was our first part. The second part asks us to find the median. Okay, so we are going to write these values as 7, then 7 plus 6, then 7 plus 2, then 7 plus 8, then 7 plus 4. So these are the 5 values which are given to us. So that will be 7, 13, 9, 15 and 11. When we have to find the median, we have to arrange them in ascending order. So we will write the ascending order of the observations will be, first will be 7, then 9, then 11, then 13 and then 15. And these are 5 values, so your n is equal to 5, which is the odd number. So our median is given as n plus 1 upon 2th term. You remember the formulas. So that becomes equal to 5 plus 1 upon 2th term, which is equal to 6 upon 2, which means the third term. And the third term is 1, 2, 3, so that is 11. And that is our answer 2. So we finished 6a. 6b is factorized. 25a square minus 9b square plus 12bc minus 4c square. Shall we write it down? And then we will start solving. 25a square minus 9b square. Now this is a square number, this is also a square number, and this is also a square number. But this is the clue. 12bc, which means 9b square and 4c square. They have been used in this particular expression, and that is a perfect square. Let us see how. 25a square minus, we will take out this minus sign common, it will be 9b square inside the bracket minus 12bc, and this becomes plus 4c square. Now check, the middle term should be 2ab. Here the value of a is 3b, here the value of b is 2c. So if you multiply them and double it, so 2ab comes out to be 12bc, and so this is a perfect square of 3b minus 2c. So we will write it as 25a squared minus 3b minus 2c whole square. So you will see this is like your a square minus b square. So you will have two brackets. You will have a plus b and a minus b. Now 25a square is the square of 5a. So 5a plus 3b minus 2c will be the first bracket, and the second bracket will be 5a minus this bracket, so minus 3b, and this will be plus 2c. After this we cannot do anything more, and so that is our answer. Question 6c. In the given figure, ABCD is a trapezium. P is the midpoint of side AD, and PR is parallel to AB is parallel to DC. Prove that R is the midpoint of BC, and find the length of PR if AB is 12 centimeter and DC is 8 centimeter. First thing we do is we draw the diagram, ABCD trapezium, and P is the midpoint. So we will show this equal to this, and we write what is given. And also we know that PR is parallel to AB is parallel to DC. So we show with the help of this arrow. To prove that R is the midpoint of BC, so R midpoint of BC we have to prove, and PR is to be found out if AB is 12 centimeter and DC is 8 centimeter. Now, whenever I'm solving a question, ideally after this, you should put the video on pause, work it out, and then check it out. All right. So you have drawn the diagram, and now let us look at our solution. The first thing we will write is that P is the midpoint of AD and PR parallel to AB parallel to DC as it was given. We know that these three lines are parallel, and we have this AP and PD, they are equal to each other, which means they are equal intercepts. So even DQ and QB will be equal intercepts, and CR and RB also will be equal intercepts. But we have to come to R, so we will look at CR equal to RB. So immediately we write CR equal to RB from statement 2 and 3, where the three lines are parallel and equal intercepts are made because of the transversal AD, and so CR will be equal to RB because of equal intercept theorem. And because CR is equal to RB, R becomes the midpoint of CB. And that is what we have proved as the first part. Then for the second part, we have to find PR. So we are going to say PQ is going to be half of AB using this triangle, and QR is going to be half of DC using this triangle. Okay, so we are going to now look at DQ equal to QB again because of this parallel to this parallel to this, and these are equal intercepts. So DQ and QB become equal intercepts. See statement 2 and 3, that is here 2 and 3, and equal intercept theorem. Got that? And if DQ is equal to QB, then Q becomes the midpoint of BD. That is from your statement 6. Yeah. Now you keep the diagram in front of you because my diagram you will not be able to see. In triangle DAB, PQ is parallel to AB because P and Q are the midpoints of AD and DB respectively. And so PQ will be half of AB. This is from statement 1 and 7. Look at your statement 1 that says P is the midpoint and 7 says Q is the midpoint. And then we write the reason as midpoint theorem, that is MPT. In triangle BCD, you will see again Q is the midpoint of BD and R is the midpoint of BC. So QR will be parallel to DC and QR will be half of DC because of statement 7 and 5. 7 says Q is the midpoint and 5 says that R is the midpoint, and midpoint theorem. Now if you take this PQ and QR and if you add, you will get PR. Let us look at our diagram. See there, PQ plus QR. PQ plus QR is equal to PR. So we are going to add these two, and PQ is half AB plus half DC is this. So PQ plus QR is PR as we saw in the diagram. Half is common and here you get AB plus DC inside the bracket. The values of AB and DC are already given, and so you have half into bracket 12 plus 8, that is half into 20, that is 10 centimeter, and that is your answer. Question number 7a. Solve the following pair of linear equations using cross multiplication method, and here we have the two equations. Let us solve them. For the cross multiplication method, we have to bring all the terms to the left hand side, and we have to make it like 2x minus 5y minus 14 equal to 0. The second equation also, x plus 2y plus 2 will be equal to 0. So remember to convert this into ax plus by plus c equal to 0 in that format. So here we'll have a equal to 2, here we'll have b equal to minus 5 and c equal to minus 14. And because it's the first equation, we'll call it a1, b1, c1. And this side, it will be a2 equal to 1, then 2y, so b2 equal to plus 2, so c2 equal to 2. Now, simultaneous equation for cross multiplication, we have to make b1, c1, a1, b1, and below that we'll have to write b2, c2, a2, b2. And now this side we will write the values. So B1 is minus 5, C1 is minus 14, A1 is 2 and B1 is minus 5. And below this, exactly one below the other, we will be writing B2 means 2, C2 means again 2, A2 means 1 and B2 once again it will be 2. Now we are going to write our formula. Our x is equal to, you have to know this by heart. It will be, right, BC minus BC. So it will be B1 C2 minus B2 C1 upon, we will have A1 B2 minus A2 B1. And this side we will write y formula, which will be C1 A2 minus C2 A1 upon this denominator, and this denominator will remain the same. So A1 B2 minus A2 B1. Got that? Now to substitute B1 C2, we will do cross multiplication like this. So this will be like so. So minus 5 into 2. So we will write it like so. Minus B2 C1. So here also it will be B2 C1. So that will be 2 into minus 14. Then let us write the numerator here this side. So for this we will have C1 A2. So we will take this way, minus 14 into 1 minus C2 A1. So we will do C2A1. So that will be 2 into 2. The denominator is your A1 B2. So we'll go this way and this way. So here it will be this way and then this way. So it will be these two multiplied. So 2 into 2 and minus sign and then 1 into minus 5. And the same thing will repeat over here. So 2 into 2 minus 1 into minus 5. Now it is simple. The only problem is this step. This you have to be very careful. This will be minus 10 and plus it will be 14 to 28 and denominator 4 minus into this will be minus 5, so plus 5. And for our y value, it will be minus 14 minus 4 and here it will be exactly the same 4 and here plus 5. So we will have 28 minus 10, that is 18 upon 9, which is equal to 2. And here it will be minus 18 upon 9, which is minus 2. So we have therefore x equal to 2, y equal to minus 2, and this is our answer. Some of your teachers may also ask you to write solution set as x and y values like so. Depends upon your teacher, and that is our answer. 7b. In the given figure, ABCD is a quadrilateral. A, B, C, D. This is the quadrilateral. BP is drawn parallel to AC. BP is parallel to AC and BP meets DC produced. BP meets DC produced at P. Prove that area of triangle AOB, that is this triangle, is equal to area of triangle COP, that is this triangle. And the second part, area of quadrilateral ABCD is equal to area of triangle APD, this one. In order to solve this, we will have to first draw the diagram on our answer sheet, and we have to also write what is given. So let us see how we write it. Given was ABCD is a quadrilateral. So we have ABCD is a quadrilateral and BP is parallel to AC. That's all we need to write. And then to prove that area of triangle AOB is equal to area of triangle COP. Now let us look at our diagram. Our AOB and COP. This is the purple triangle and this is the blue triangle. They have to be equal in area. Now, if they are equal in area, then we must make use of these parallel lines. Okay. Now look at this. If we take AOB triangle and if we add AOC to that, we will get this triangle here like so. This one. Okay. And if we are adding this orange triangle to COP, then we will get this triangle. Can you see that? Yeah. Now, what can you say about ABC triangle and ABC triangle. They are having the same base and they lie between the same parallels. And so we are going to start writing our solution. Our point number 1 is that BP is parallel to AC, and that is given. Statement number 2, area triangle ABC will be equal to area of triangle APC, and this will be because of statement 1, and areas of triangles having same base, that is AC is the same base, and between same parallels, that is AC and BP, they are equal. Okay, now statement number 3. Your ABC is made of purple triangle and the orange triangle. So we will write area triangle AOB plus area triangle AOC is equal to this one, APC becomes area triangle AOC plus blue triangle, that is area triangle COP. Okay, now this will be because of the diagram. Now you will see AOC from both sides, both the triangles will get cancelled, and then fourth one will have therefore area triangle AOB is equal to area triangle COP. This will be from statement 3 and proved the first part. Got that? Now next part, they are asking us area of quadrilateral ABCD equal to ABP. Now area of ABCD will be this triangle ABC plus APC, and area of triangle APD will be this blue triangle and orange APC plus ADC. So we are taking statement number 2. That is ABC triangle and APC triangle. To each of them we will add ADC. So to statement number 2 we are adding this area. So let us see how we write it. Statement number 5 is area triangle ABC plus area triangle ADC will be equal to area triangle APC plus area triangle ADC, and here it will be from statement 2 adding area triangle ADC to each side. Now let's look at the diagram. We have written ABC plus ADC. ABC plus ADC is quadrilateral ABCD. So we will write just that. Therefore, area quadrilateral ABCD is equal to, so we got these two. Now APC and ADC, let us look. APC plus ADC is ADP triangle. So that is area of quadrilateral ABCD equal to area of triangle APD, and this is from diagram and statement number 5 and proved second part. So that is how we solve this question. This was our 7B question. Now let us look at 7C. The cost of mowing a circular field at rupees 16 per square meter is rupees 2464. Find number 1, the total area of the field, the radius of the circular field, and the cost of fencing the field at rupees 12 per meter. So we write down the data, and remember it's a circular field. So I'll just show a diagram like this, and this is the area to be mowed, and that area for mowing costs 2464 rupees. So if I want the area, I'll say 1 meter square costs 16 rupees. So these many rupees will be for how many square meters? So we will have area of a circle will be equal to the total cost upon the rate. That will give us 2464 upon 16, and that gives us 8 2s, 8 3s, 8 0s, 8 8s, 2 1s. So it is 154 meters square. But area of circle is formula wise, it is pi r square. So we got to connect it with the formula. So 154 is equal to 22 upon 7 into r square. Therefore, our r square is equal to 154 multiplied by 7 upon 22. 22 goes 7 times here. which is equal to 49. Therefore, radius is equal to 7 meters. Now, area of the circular field, we got this. We found our radius also 7 meter, and this was our answer 2. And then the third part is find the cost of fencing. Now the fencing will go right round, which means you have to find the circumference. So circumference is 2 pi r, which will be 2 into 22 upon 7 multiplied by radius is 7. 7 gets cancelled and we will have 44 meter. And so the cost of fencing at the rate of rupees 12 per meter will be equal to rate multiplied by the circumference. That will be equal to 12 multiplied by 44. It comes out to be rupees 12 fours 48, carry 4, 12 fours 48 and 4 52. So we have 528 rupees, and that is our answer 3. So we have finished with question number 7. Question number 8 is a trigo question. In the given triangle ABC, AD is perpendicular to BC, AB is 13, that is this, BD is 5 centimeter and DC is 4 centimeter, and we have to find the value of AD and then tan x plus cot y, where this is y degrees and this is our x degrees. So the question is to find AD. We first draw the diagram. Now what I want you to do is every time you see me solving this, you draw the diagram, you put this video on pause and start writing on your own. And when you're stuck, then you look at the video and check your steps. Alright? So AD is part of this triangle, right? And we have 13 centimeter, 5 centimeters, and we have to find AD. So we will write in right triangle ADB by Pythagoras theorem. We will have AB square equal to AD square plus BD square. So it will be 13 square is equal to AD square plus 5 square. We are just substituting the values. Therefore, AD square will be equal to 13 square minus 5 square, which is 169 minus 25. And so our AD will be under root 144, which will be 12 centimeter. So this becomes our answer 1. So we will write here 12 centimeter in the diagram for AD. Now they are asking us tan x and cot y, these values. So for tan x, we have to take this triangle and tan x will be opposite, that is DC upon AD. Okay, so we will say tan x degrees will be equal to DC upon AD, which is 4 upon 12, which is 1 upon 3. Then we will look at cot y. Now cot y degrees is equal to, for y we have to take this triangle ABD. Y will have tan equal to AD upon BD. So cot will be BD upon AD. BD is 5 and AD is 12. 5 upon 12. Okay, that is your cot y. Now we are asked to find tan x plus cot y. So we will write it on this side. Tan x degrees plus cot y degrees will be equal to tan x value we had got as 1 upon 3 plus this is 5 upon 12. So we will take the LCM, which is 12. So 3 4s 12 and 12 ones. So here it will be like so. And we will get 9 upon 12, which is 3 upon 4. And that is our answer. Now we come to question 8b. Log a to the base 2 is equal to 3. Log b to the base 3 is equal to 2, and log c to the base 4 is equal to 1, and find the value of 3a plus 2b minus 10c. So we have to find the value of 3a plus 2b minus 10c. So if we are given the values of log a to the base 2 equal to 3, we can easily say that 2 to the power 3, and that is the value of a. So we'll have a equal to 2 to the power 3, and here we will have 3 to the power 2 will be b, and 4 to the power 1 will be the value of c. Okay, now we will write this 3a plus 2b minus 10c equal to 3 into bracket a means 2 to the power 3 plus 2 into bracket b means 3 to the power 2 minus 10 into bracket c means 4 to the power 1. So that gives us 3 into 2 to the power 3 is 8 plus 2 into 3 square is 9 and minus 10 into 4 to the power 1 is 4. So that gives us here 24 plus 18 minus 40. These two give you 42 minus 40 and so we'll have 2 which is our answer. 8c. Use the graph paper for this question. Draw the graph of 3x minus 2y equal to 5 and 2x is equal to 3y on the same axis. Use 2 cm equal to 1 unit on both the axes and plot only 3 points per line. Write the coordinates of the point of intersection of the two lines and also find the area of the triangle formed by the lines and the y-axis. Now look at this graph paper. We have written the scale on both axes as 2 cm equal to 1 unit, just as it was given in our question paper. So we have divided this, the length of it and the breadth of it. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, and this way also there will be 10 squares. It's a square. So on the fifth line we have drawn the y-axis and then we have drawn 1, 2, 3, 4, 5. After 5 boxes we have marked this line over here. This is your x-axis. For every 2 centimeters we write here 1 unit, then another unit, then another unit. So on x-axis we have marked 1, 2, 3, 4, 5. This side minus 1, minus 2, minus 3 up to minus 5. Above the x-axis here 1, 2, 3, 4, 5 and then below also it will be minus 1, minus 2 going up to minus 5. For a graph question, that is 8c, we will first write the equations and we will make y as the subject of the equation. So take 2y this side, so it will become positive. 5 comes this side, so it becomes 3x minus 5 equal to 2y, and so y is equal to this upon 2. So 3x minus 5 upon 2 we have written. Then we have to make the table because we have to plot the values. When we have to plot the graph, x values we have to take in such a way that our y will be a whole number. So now by trial and error, I have got these values, x equal to plus 3, minus 1 and 1. So if it is plus 3, then 3 3 is 9, 9 minus 5 is 4, 4 upon 2 is 2. If I take x equal to minus 1, this becomes minus 3, minus 5 makes it minus 8 upon 2, that is minus 4. If it is 1, then 3 ones 3 minus 5, that is minus 2 upon 2 gives us minus 1. Our second equation is 2x is equal to 3y. So y is equal to 2x upon 3. So we make the columns here x and y equal to 2x upon 3. And here again I am going to take 3 values of x, minus 3, 0 and 3. Now I have to take x as a multiple of 3 because we have to divide by 3. So 2 into minus 3 minus 3 gets cancelled and minus 1 into 2 will give us minus 2. If x is 0, 0 upon 3 will be 0. So 0 and 0. When it is x equal to 3, then 2 into 3, 3 gets cancelled and you will have 2 as the value of y. So what are our points to be plotted? 3, 2, minus 1, minus 4, 1, minus 1 for this line, and minus 3, minus 2, 0, 0 and 3, 2 for this line. Okay, so let us see how we plot the points. Now I have written the table here. So the first point to be plotted is 3, 2. So this is 3 and this is 2 and this is our point I'm marking it with ink because pencil will not show so clearly. The second point is -1 comma -4. You can rewind and just have a look at it. -1 comma -4. So we have -1 is here and y is -4, which is here. So this is our second point. And 1 comma -1. So 1 comma -1, this is our third point. So we are going to join these 3 points. You can see the 3 points. So you can see the graph. Now after you join the points, you have to write the equation of this line like so. Now for our second line, our points are here -3 comma -2, 0 comma 0 and 3 comma 2. So this is a -3, -3 and this is -2. So this is our first point. Then we have 0 comma 0, that is this point, and then 3 comma 2 is the same this point. So now we are going to join this also. If I use the pencil, it will become too light and you will not be able to see clearly. So the point of intersection is this one. This is 3 comma 2 and let us call that point as P. Okay. I have written 8C, point of intersection P 3 comma 2, that is answer 1. For the second part, they are asking us to find the area of the triangle formed by the lines with the y-axis. With the y-axis, this is the y-axis and these are the two lines. So let us call this point as O and this we will call as A. So it will be the area of triangle OAP. It will be half of this base and this height. Now base is here 1 unit, 2 unit and this is half a unit. So base is 2.5 units and the height is 1 unit, 2 unit, 3 units. So we will write area of triangle formed by the lines with y-axis is the area of triangle OAP, which will be half base into height. Now half base is 2.5 units and the height is 3 units. So that gives us 7.5 upon 2, which is equal to 236, 2 7s 14 and 2 5. So 3.75 square units. And this is our answer 2. Okay. Question number 9a. Solve for x. We have cube root of 3 upon 5 bracket to the power 2x plus 1 is equal to 125 upon 27. We convert this cube root as power 1/3. So 3 upon 5 is to the power 1/3. And then this bracket we write as box bracket to the power 2x plus 1. 125 upon 27 is cube of 5 upon 3 because 125 is 5 cube and 27 is 3 cube. So we write it like so. Now in the next step we will write 3 upon 5 bracket to the power 1 upon 3 into 2x plus 1 and we place a bracket here because this whole bracket is divided by 3. That is equal to, here we are going to now look at the base 5 upon 3 to the power 3, but here it is 3 upon 5. So we are going to make a reciprocal of this. This will become 3 upon 5 to the power minus 3. Now here we will have to write the reason because a to the power m bracket to the power n becomes a to the power mn, which we have used here, and here we have used the fact that a to the power n is equal to 1 upon a to the power minus n. So our next step will be 3 to the power 5 to the power 2x plus 1 upon 3, and that is equal to 3 upon 5 to the power minus 3. Now we will equate the exponents because the bases are the same. So that will give us 2x plus 1 upon 3 is equal to minus 3. That gives us 2x plus 1 equal to minus 9. So we have now 2x is equal to minus 9 minus 1, that is 2x equal to minus 10. That gives us x equal to minus 10 upon 2, which is minus 5, and that is our answer. Question 9b. If 1 is subtracted from the numerator of a fraction, it becomes 2 upon 3, but if 5 is added to the denominator of the fraction, it becomes 1 upon 2. Find the fraction. Now, when the question is find the fraction, remember the fraction has the numerator and the denominator. So we'll say let the numerator become x and denominator be y. So we written just that, let the numerator be x, denominator y. Fraction becomes therefore x upon y. Your first condition says if 1 is subtracted from the numerator. So the numerator is x and you subtract 1. So the fraction becomes x minus 1 upon y. And this fraction, they say, is 2 upon 3. So that becomes your equation 1. If 5 is added to the denominator, then the denominator becomes from y, it becomes y plus 5. Numerator remains the same. And this now becomes half. And that is your equation 2. So now we have the two equations which we will simplify. So here we will cross multiply. So 3x minus 3 is equal to 2y. Therefore 3x minus 2y equal to 3. That's our equation 1. Here we will cross multiply the second equation. 2x is equal to y plus 5. Therefore 2x minus y is equal to 5, and that's our equation 2. Now I'm going to use the elimination method. So I'm going to multiply the second equation by 2 so that this will become 2y and then it will get cancelled with this. So let us see. Therefore this becomes 4x minus 2y is equal to 10. This is your equation 2. Now we will write both the equations together. So we have 3x minus 2y equal to 3 and 4x minus 2y is equal to 10. And now we will subtract equation 2 from equation 1 so that 2y gets cancelled. Here you'll have minus x equal to minus 7. Cancel the minus sign. Therefore x is equal to 7. And we'll substitute in equation 1. So 3x minus 2y is equal to 3. Substitute the value of x. 3 into 7 minus 2y is equal to 3. 21 minus 2y is equal to 3. Minus 2y is equal to minus 21 plus 3. So minus 2y is equal to minus 18. Cancel the minus signs. Y is equal to 18 upon 2, which is equal to 9. Therefore, the fraction is going to be x upon y, which is 7 upon 9, and that is our answer. In your 9C, we have been given a diagram here, and we are told that PS, that is this, QS, that is this, and RS, that is this. They are the bisectors of angles PQ and R respectively. Okay, so we are going to call these small p, these two. These two angles will be small q, and this will be small r and small r. Okay, if angle PRQ is this full thing, is greater than angle PQR. PQR, that is this. Then we have to prove that SQ is greater than SR. Now SQ and SR means we have to look at this triangle. Okay, so let us see the first things first. Let us write the first part. First part we will say angle PRQ is greater than angle PQR. This is given. Okay, now PRQ is R plus R. So we have 2R is greater than 2Q. This will be from statement 1 and diagram. Now, of course, before we do this, we have to write PS is bisector of angle P, QS is bisector of angle Q, RS is bisector of angle R. Okay, so therefore we will have to say angle QPS equal to angle RPS equal to small p, angle PQS equal to angle RQS equal to small q, and angle PRS equal to angle QRS equal to small r. Now these statements I'm omitting because I've directly decided to teach you the knack of solving this question. Okay, so we will have therefore R greater than Q. Okay, because we are going to divide this by 2. So you will have R greater than Q. Now we have to concentrate on this triangle. Now if R is greater than Q, then opposite this R is SQ. So SQ is greater than opposite Q is SR. Reason? Statement 2, and we are going to say that side opposite greater angle is greater in triangle SQR. Okay, so we have got this, the first part, we have proved the first one. Now in the second part, they say if PRQ is 110, so angle PRQ is equal to 110, which is given. Therefore 2R is equal to 110 degrees. Therefore R is equal to 55 degrees. Okay, so this becomes 55 degrees, this becomes 55 degrees. Angle PQR is 40, that is this one. So we will write that again, we'll say given. Therefore 2Q, therefore Q is equal to 20 degrees. So this is 20 degrees, this is 20 degrees. Now they are telling you prove that SP is greater than SQ. Now SP is greater than SQ means now we have to take this triangle. Okay, now if you have this angle is 40, this as 110, then the sixth statement will be angle P, that is angle QPR is going to be equal to 180 degrees minus 110 plus 40, that is 150 degrees, which is going to be 30 degrees, which will be 2P. So P will be equal to 15 degrees. So we write here 15 degrees and 15 degrees. All right. Now we have to look at this triangle. So in that we'll have the relation between P and Q. Q is greater than P. So we will say in statement 7, in triangle SQP, we have angle Q is greater than P right over there, since 20 degrees greater than 15 degrees. Now opposite Q is SP. Therefore SP is greater than opposite P is SQ. And that is what they asked us over here. Can you see that? So this will be from statement 7. And again, we will repeat the statement that we have written out here. That is side opposite greater, angle is greater. Okay, so that gives us a second part which is proved. That finishes our 9C. Let us come to question 10. Question 10A, evaluate without using the trigonometric tables. Now, trigonometric tables means the log tables which give you like sine of 40 degrees, sine of 50 degrees. Do not use that. Use the other rules from trigonometry to evaluate this. So I've written this question down and I'm going to group these two together and these two together. Why did I do that? Because 20 degrees and 70 degrees, they give you 90 degrees as the sum. And 40 degrees and 50 degrees also give you 90 degrees as the sum, which means these two are the complementary angles and these two also are complementary angles. All right. So we will write them together as tan 20 degrees into tan 70 degrees into tan 40 degrees into tan 50 degrees. Now we'll group this together, and this 20 we will write in terms of 70. How? Tan 20 degrees becomes tan of 90 degrees minus 70 degrees. 90 minus 70 is 20, but in this particular tan we must get 70 degrees. So how do we write it? 20 degrees as 90 degrees minus 70 degrees into tan 70 degrees, okay? Into tan 40, we will write in terms of 50, means 90 degrees minus 50 degrees. Into tan 50 degrees, this as it is. Now tan 90 minus theta is equal to cot theta. So we'll write this as cot 70 degrees into tan 70 degrees. Into here, this will be tan 90 minus theta as cot theta. Here theta is 50 degrees, so cot 50 degrees into tan 50 degrees. Now we know that cot is 1 upon tan. So we will write this cot 70 as 1 upon tan 70 degrees into tan 70 degrees into this becomes 1 upon tan 50 degrees into this as it is. So tan 50 degrees, and then you will see when we cancel this, you will get 1 multiplied by 1, which is 1. So our evaluation answer is 1. Got that? 10b is factorize. So let us start factorizing. Now here there are 4 terms and we have to factorize this. So we will group them. If we take first two, what is common? X squared. If you take out x squared common, inside the bracket, what do you get? From x cube, x squared is gone, so you get x minus, here from 3x squared is gone, so you will get minus 3. Between these two, what is common? This is minus x, so minus 1 is common. Into bracket, this will have x remaining because minus 1 is common. This x will be positive inside the bracket and this plus sign becomes minus 3 because from plus 3 we have taken out minus 1 as common. Now you will see that in this term and this term, this is common. So we will take x minus 3 common and we'll have x squared minus 1, which in turn can get factorized as x plus 1 into x minus 1 using a squared minus b squared is equal to a plus b into a minus b, and that is our answer. Now we come to question 10c. In the figure, O is the center of the circle. Arc AB is equal to arc BC equal to arc CD. So arc AB is equal to arc BC is equal to arc CD. Angle OAB is 48 degrees. OAB. This is given as 48 degrees. Find angle AOB. So this is the first one that has to be found out. Then angle BOD. BOD, that is this one, is your B, let us say, and OBD. OBD. So we have to join this. OBD is this one, which is angle C. This is to be found out. Okay. Now, to begin with, in this triangle, we will have OA equal to OB. They are the radii. Correct? So let us write that in triangle AOB, AO equal to BO equal to radii. Okay, so opposite AO is this angle and opposite OB is this angle. They are going to be equal. So this also will be 48 degrees, but we'll call this as X and X. So we'll say statement number 2, therefore angle opposite AO will be angle ABO equal to opposite this will be angle BAO equal to X equal to 48 degrees. And here you are going to write the reason from statement 1 as angles opposite equal sides are equal. Now in this triangle, we'll have 48 plus 48 plus A equal to 180 degrees. So we will say also A plus X equal to 180 degrees. And that is because angles of triangle AOB are supplementary. Okay, so A plus 48 means 96 degrees is equal to 180 degrees. Your A will be equal to 180 degrees minus 96 degrees. This will be 84 degrees. And that is your angle AOB. Angle AOB. That becomes your answer 1. Alright, so we will write over here this one. This is 84 degrees. Okay, now we have to come to this angle. Okay, so we will have to do this construction, join OC. So you will see that arc AB, arc BC, arc CD, they are equal. So they will subtend equal angles at the center. So if this is A, this will be A and this also will be A. Correct? So let us write that. Statement number 4. Arc AB equal to arc BC equal to arc DC. This has been given. Fifth statement, therefore angle AOB equal to angle BOC equal to angle DOC equal to small a, and this will be from statement 4 as equal arcs subtend equal angles at the center. Statement number 6, we have to find this B, that is angle BOD. So angle BOD, which is equal to small b, is equal to A plus A. Can you see that? Which is equal to 84 plus 84, which is equal to 168 degrees. Okay, and here we have used statement 3 and statement 5. That's how we got this 168. This is our answer 2. So in our diagram, we have managed to get this angle B is 168. Correct? Now, statement number 7, I shall write over here. We have to find this angle C. So we have to make use of this triangle. See this triangle here? Yeah. Now in this triangle, you will see this is 168 and this is small c. So this angle also will be small c. Why would it be small c? Remember, statement number 7 will have to say that OD is equal to OB equal to radii. So statement number 8, we will have therefore angle OBD equal to angle ODB equal to small c. And this will be from statement 7 because angles opposite equal sides are equal. Then statement number 9, in triangle OBD, we will have small b plus c equal to 180 degrees. Reason, angles of triangle OBD are supplementary. Okay, now what is the value of b? 168 plus 2c is equal to 180 degrees. Therefore, 2c is equal to 180 degrees minus 168. Correct? So, 2c is equal to, it will be 12 degrees, and c will be equal to 12 upon 2, which is 6 degrees. What is c? Angle OBD. So, angle OBD is 6 degrees, and that is our answer 3. Question number 11. ABCD is a parallelogram in which angle DAB is 80 degrees, this one, and bisector of A and B meet CD at P. So these two angles will be 40 degrees and 40 degrees, correct? Prove that AD is equal to DP. So this AD is equal to DP is the first thing we have to prove. Then CP is equal to CB. This is the second thing we have to prove. And DC is equal to twice AD. This is the third thing we have to prove. Okay. Now our thinking step will be, if this is 80 degrees, this angle is going to be 100 degrees because angle A and angle B, they are co-interior angles, as AD and BC, they are parallel, and AB is the transversal. So this angle becomes 50 degrees and 50 degrees. Okay. Also, if this is 80, this will be 100 degrees, correct? And if this is 100, this will be 80 degrees because this angle and this angle, they are again co-interior angles. All right. Now, in this triangle, this is 100, this is 40. So this will turn out to be 40, yes. In this triangle, this is 80, this is 50. So this also will turn out to be 50. Also, you can say this is alternate angles. Can you see that? Either say 80 plus 50 plus this angle is 180 degrees, or say that these two are alternate angles. Here also this angle this way, this angle here, and this angle over here, they are alternate interior angles, correct? So now if this is 40 and this is 40 degrees, then in this triangle, this will be equal to this, correct? So if these two are equal, because the sides opposite equal angles are equal, correct? So that gives us our first answer. AD equal to DP, correct? Now we have to prove that CP is equal to CB. Now CP and CB, in this triangle, this is 50, this is 50. So this one and this one, these two sides will be equal because sides opposite equal angles are equal. So you have CP equal to CB. You have proved this also. Now we are coming to the third part. DC is equal to 2AD. Now, do we know that your AD and BC, they are equal? So if this is A, this is also A. If this is A, this is A. If this is A, this is A. So can you see that your DC is equal to twice AD or twice BC, correct? Let us see how we write it. So this is our solution. You can take a screenshot of this or you can pause it and write it down. These are the 12 steps. And now let us look at the remaining steps. Hope you have drawn the diagram. Otherwise, you can just go back and check the diagram. And these are the steps 13, 14, 15. You can pause it, take the screenshot, write it down, and we have got the answer of this question. Question 11b, given 3 points P, A, B, the coordinates are given, and they have given that PA is equal to PB, find the value of K. Let us see how we do this. So to begin with, we write the coordinates of P, A and B as it is given, and we write that PA is equal to PB. These are the two distances which are equal and the coordinates are given. So we have to use the distance formula. We write the formula and then we substitute. For PA, we substitute this way. So we have x2 minus x1 will be this 2 minus minus 1. Okay, that will become 2 plus 1. And here y2 minus y1 becomes k minus 2 whole square. So we open the brackets and we get this. This is the value of PA. Now for PB, we will take this as x1 and this as x2. So x2 minus x1 becomes k minus minus 1 means plus 1. Okay, minus 1 minus 2, that will give us here minus 3 whole square. Then when we open the bracket and simplify, we get this. Now we know that PA is equal to PB. So we write the value of PA, what we've already obtained earlier. And this PB we'll write like so. Squaring both sides, this root sign will go. And we will have this equal to this. K square gets cancelled. This minus 4k goes this side, so it becomes 6k. And this comes here, so it becomes 13 plus 8, which is 21. And k will be equal to 6 goes here. It divides 21, so 21 upon 6. We have 3 7s, 21, and 3 2s, 6. So we have 7 upon 2 as the value of k, which is 3.5 or 3.5, and that is our answer. Let us look at the last question. The length, breadth, and height of a closed wooden box are 20 centimeter, 12 centimeter, and 8 centimeter. And it's a closed wooden box. The thickness of the wood used to make the box is 10 millimeter. Find the volume of the wood, the cost of the wood required to make the box if 1 centimeter cube of wood costs 8.50. Now to begin with, when we have something like this, it's always better to have a diagrammatic representation. So let's just do that. So I have drawn this box, the external length from here to here. This is 20 centimeters and the thickness of the box is 10 millimeters, which means it is 1 centimeter. Okay, so the internal length is going to be 20 minus this 1 centimeter and 1 centimeter, which means 20 minus 2, that is 18 centimeter. Now your breadth, the external breadth is going to be 12 centimeters. Okay, so the internal breadth is going to be 12 centimeters minus 2 centimeters. So 1 centimeter gone from here, 1 centimeter gone from here. So we will say that external length is equal to 20 centimeter. Therefore, internal length is going to be 20 minus 2, which is 18 centimeter. The external breadth is 12 centimeter. Therefore, internal breadth is 12 minus 2, which is 10 centimeter. Then we have the external height equal to 8 centimeter. Therefore, internal height will be 8 minus 2, which is going to be 6 centimeter. So this is the height, but from here 1 centimeter is gone, from here 1 centimeter is gone. Okay, so we have to find the volume of wood. Now the volume of wood is going to be external volume minus the internal volume. Okay, so that will be here 20 into 12 into 8 minus the internal volume will be 18 into 10 into 6. Okay, so that gives us 1920 minus 18 6 is 108. So 1080, which is 840 centimeter cube. And that is our answer 1. The cost of the wood required to make the box if 1 centimeter cube costs this. So the cost is going to be equal to volume multiplied by the rate. Okay, volume is 840 centimeter cube multiplied by 8 0.50. That is 84 multiplied by 85, which is rupees 7140. And this is our answer too. So with this, we have finished with this entire paper, and I hope you have understood the knack of solving the questions, how to think on the spur of the moment, how to connect the data with the formulas. And I hope that as you appear for the examinations, all of you will do exceedingly well. So all the best, God bless you, and keep this in mind that I'm soon bringing up my online course. So keep looking out for the instructions. All the best. Thank you for your time.